So yes, I'm from Australia, National ICT Australia. We are an R&D organisation, a scientific organisation, but we're focused on IT and data science. So most people here, of course, are engineers. We're not, but we're involved in this space because the Road Authority in Australia came to us and said, we have a problem with this particular bridge, and our engineers can't seem to find a solution to this problem. So maybe you can help. So the bridge in question is the Sydney Harbour Bridge. It's fairly long. It's 1.2 kilometres long if you include the approaches. And it'll last forever if you ask the asset manager, as with most civil infrastructure. The problem that we have here is that the bus lanes which go along the bridge are getting old. It's about 80 years old. These structures are concrete and steel. They've had a lot of weathering. The engineers tried doing FE models to try and understand what was going on and really couldn't find a practical way of assessing the condition and predicting the maintenance needs of the structure. So today we're really concerned. So this is actually now a bus lane where the tram is. Back in these days they used to stop the tram halfway across the bridge and people would get out and have a look and take some photographs. But now it's a very busy road, it's a bus lane, and underneath this bus lane are about 800 structural supports. These jack arches are about 1.5 metres wide, and the issue here is how do we keep an eye on those structures and be able to detect when they're beginning to show some signs of damage so we can go and do some preventative maintenance. The issue right now is that to get to these things you need to abseil down or rappel down or maybe use a machine to come up. So it's quite difficult to access, and although there's 800 of these structures which should be identical, they're not. So when it comes to doing things like FE models, there's so many variables and unknowns, it's very difficult, in fact impossible, to prioritise one of these 800 over the others. So one of our strengths is machine learning and data analysis. Other strengths are things like computer vision and optimisation. But in this case, we're using machine learning to analyse sensor data, basically to detect anomalies. So although we're moving to predictive analysis, we're starting with anomaly detection, saying can we monitor the behaviour of these assets or these components, and then try and let the asset owner know that there's a problem or a potential problem, so we can go and do some further inspection and preventative maintenance. So this is about 2 years ago. It started as a research project, more or less. There was no hardware available in the field, in the market to do this cost effectively. There's 2,500 sensors on the bridge. They're accelerometers, they're MEMS accelerometers like you have in a mobile phone, so they're quite noisy, but they're good enough, and we can overcome some of the limitations with these sensors through software. They're linked together I won't go into the details today, but if you might talk tomorrow, I might talk a bit more about the underlying infrastructure. It's a 1.2 kilometre long fibre optic backbone with about 800 small computers running close to the sensors. They do some data analysis. All the information goes back to a website, because the asset owner has an app that he uses to keep an eye on his bridge. So there's a couple of techniques that we're using. Foremost among them is a machine learning technique. We're finding with lots of different, and it's a support vector machine, which is a fairly straightforward technique, but there's others we're looking at to detect anomalies. Over time, we're now looking at tracking vehicles as they move along the bridge to try and characterise the loading. So it's just like instead of using a controlled load, we can use ambient traffic, and we can actually track individual buses as they move along. And then some other types of analysis, including using ambient vibration, not just the excitations generated by buses. That's the need and what we're doing. The actual system is this here. This is the website that the asset owner uses. We're still commissioning the system, still rolling it out. They're actually deploying the sensors. And what we're seeing here is, I guess, a dashboard. He's not really an engineer, he's an asset manager, so what he wants to know is whether he needs to do anything or not. If everything's green, he doesn't need to do anything. So although there's engineering data behind some of this stuff, he doesn't want to know about that. So there's other people who can look at this. He has a number of different structures in Sydney. The first one is this Harbour Bridge, and we're looking at lane 7. This is the particular application here. Another part of the bridge will use a different sort of sensor, different sorts of analysis, and possibly use things like finite element modelling as part of the solution and some more traditional engineering techniques. So you can see here that everything's green. He's had a couple of sensors which have fallen off because they're glued on, and paint does peel, so he knows that he has to send some people out sometimes to reattach sensors. But what he can do, if he really wants to know more, click on the link there, and this is the condition of the bridge. So it's halfway through the rollout. As I said, they're rolling out the sensors themselves, and essentially what we can see is the whole structure. There's 800 of these components, and it's a hierarchy. So we have the bridge at the top level, we have these approaches and the various parts of the main span underneath that, and as you go further down, we have more and more detail. You can basically click right through, because I think I'm near the end of my 5 minutes. We can click right through. So let's say we look at the northern approach. You can see the northern approach. Click on one of the spans, and we can just keep drilling right down to see a particular lintel. This is real data right now, so this is 4 minutes ago. If he really wants to know more, he can click on that lintel and get some more information about the different algorithms we're running. He really doesn't need to know this. But for peace of mind, he can show people. And there's a bit of historical information about machine learning and other techniques. Is that my 5 minutes? Okay, thanks.
So.